You know that feeling, right? When you're talking to a voice assistant and there's that awkward pause, that little moment of silence where you just know you're talking to a machine. Well, today, we're going to pull back the curtain on what it really takes to close that gap, to make AI voices sound truly, convincingly human, and in real time. And it all comes down to a matter of milliseconds.
So, why is this so incredibly hard? I mean, think about it. We humans have spent thousands of years perfecting the way we talk to each other. Conversation is supposed to be this seamless, fast-paced dance. And getting a machine to jump into that dance without stepping on everyone's toes, well, that's one of the single biggest challenges in AI today.
And here's the magic number: 800 milliseconds. That's the benchmark for a voice AI to hear what you said, think about it, and start talking back. If it takes any longer than that, our brains immediately flag the conversation as unnatural, as clunky. To put that in perspective, a human can respond in as little as 500 milliseconds, so that is an incredibly tight window to work.
Right, so that 800 millisecond goal creates this massive technical hurdle. Because, let's be honest, we don't just want a fast response. We expect a whole lot more from it.
It's never just one thing, is it? It's everything all at once. We expect an AI to be a good listener, one that doesn't interrupt us. But it also has to be smart and conversational enough to get the context. We want it plugged into real-time data, and of course, we want its voice to sound natural, not robotic. The real challenge is that every single one of these expectations puts even more pressure on that fast response time. Nailing all of them at the same time, inside that 800 millisecond window, that's the mountain that developers have to climb.
So how on earth did developers even begin to tackle this? Well, the answer lies in something called orchestration. You basically need something that can act like a conductor for a really complex AI orchestra. And a great example of this is a framework called PipeCat. You can think of it like a multimedia pipeline. It takes in audio from the user, passes it to all the right services in exactly the right order, and then sends the final audio back out. It's the conductor that keeps the entire symphony perfectly in time. Now, the traditional way to build this is what's called a cascaded model. And really, it's just a relay race against the clock. Your voice comes in as audio. That audio has to be converted into text. That text gets sent to a large language model, like a Gemini or GPT, to come up with a response. Then the model's text response has to be converted back into speech, and only then do you finally hear it. Every single handoff in that chain adds precious milliseconds of delay.
But here's the good news. That entire complex process is now being simplified thanks to a major evolution in the AI models themselves. We're moving away from that clunky multi-step cascade to something much more direct.
And this chart just shows the difference so clearly. On the left, you've got that old cascaded model, that whole audio to text to text, text back to audio flow. But the new speech-to-speech models on the right, they just cut out the middleman. It's audio in, audio out. That's it. This just dramatically chops down the latency and makes the code so much simpler to manage.
And you don't have to take my word for it. As Mark Bachman from Daily puts it, with this new approach, things get dramatically simplified. For developers, that means less time wrestling with different services and a lot more time focusing on actually creating a great user experience.
Now, that simplification is powerful, no doubt, but it's only half the story. The real magic of an orchestration framework like PipeCat is the incredible flexibility it gives developers. It's this idea best described as plug and play.
The whole idea, as developer Ali's explains it, is modularity. You aren't locked into one specific set of tools. You can literally mix and match. A developer can basically build their own custom AI stack from this toolbox. So you want to use DeepCram for speech-to-text, then OpenAI's model for the brains, and maybe Cartesia for a super realistic voice? No problem at all. You can swap these services in and out without having to rewrite your entire application from scratch. And the really crucial point here is that this goes way beyond just swapping parts. This level of orchestration opens the door to some seriously advanced capabilities.
Things like having a backup provider ready to take over instantly if one service fails. That's called failover. Or even running separate logic for audio and video at the exact same time in a more complex agent.
Okay, so when you combine this real-time speed with this incredible flexibility, you start to unlock possibilities that go way, way beyond just simple question-answer chatbots.
We're really moving into an era of truly interactive AI experiences. This isn't just about getting information anymore. It's about collaboration, it's about entertainment, and it's about completely new ways for us to play. And a perfect example of this is a game called Word Wrangler. It's basically like that party game catchphrase, except your partner is an AI. You have to describe a word without actually saying the word, and the AI has to guess it. Now, to pull that off, the AI has to understand all the little things, the nuance, the context, the subtle clues in your voice, and it has to do it all in a fraction of a second. It's a fantastic demonstration of where this is all going, toward AI that's truly intuitive and works in real time.
And that just leaves us with a pretty fascinating thought. We've gone from these clunky, slow voice assistants to an AI that can actually play an intuitive word game with us. So as these systems get even faster and sound even more natural and get more integrated into our lives, what comes next? What problems are we going to solve, and what new experiences are we going to create? The conversation, I think, is just getting started.